Okay, guys, this is the next scene that we're doing. This is called, what is it called? It's called the queue of items counters. So this is the code for my entry conveyor. The counter that detects every single parts that has been emitted over here by this emitter device. It counts every one of them and then waits for the sensor to clear its leading edge and its trailing edge, and then moves forward, turning on this conveyor and doing the same over here. Over here, we wait for this sensor here, normally closed, to clear both edges. Once that's done, we need to stop the conveyors. So if there's no load or product on the conveyor, the most efficient way to program this logic is to stop the conveyor, those stopping the waste of energy, right? So let's go ahead and run it a couple times, and then once we have several items on the conveyors, we are going to turn off the emitter to see if that indeed that behavior, we can observe that behavior. So we are already online with the PLC. Right here we have the run mode. We're not using any of these input or outputs, so we're using internal variables only. So on this logic, I'm using the counter up and down to make sure we get this done. So my count down and my count up is coming from this instruction. This is the falling edge one-shot instruction. I'm getting that from the emitter over here, if factory IO is running, of course, and then I get this contact closure. Then I'm able to count up. At the same time, at the end of the second conveyor, I am able to subtract that count from my count up and down. All right. So let's go ahead and run it a couple times and see how it looks. Right. All right. Let's do it. So this is the emitter. So now I'm going to turn off the emitter. 1, 2, 3. Good. Both conveyors were shut off because my counter is no longer counting, it's 0. So my logic here, for this to take place, for this logic to run, this is my entry. Let's do the entry first. So for the logic, my stepping logic here, as you know, I always use stepping logic. So this requires that this bit, factory IO running, be on all the time. If it's not, nothing happens. So where is this bit come from? So this bit is come from here. Switch between edit and run mode. So I'm going to click it. Now I'm stopped. So that bit should go away now. See, it's blue. Red, it's sensed. The contact is closed. But blue is waiting for this sensor or signal to activate. So I'm making a comparison here. If my counter is greater than 0, well, go ahead and do this step one complete cycle of this entire stepping logic from step 1 to step 2 to step 3, clear everything, and then ask the same question once again. Do we have a load on the conveyor? Yes or no? If we do, run again. The same thing exactly happens with my exit conveyor. It's just a variable that changes a little bit. So this is what we get. we get actually this bit. I forgot to completely erase it because we're not using this bit anymore. Because now both programs right here, you can see that I created only three programs: my entry, my exit, and my counter. So any one of them runs automatically in auto mode if factory IO is running. That's the only bit that is waiting for in order to kick in. All right. Well, I hope you like this video. Next time we're going to go ahead and do the next one, which is, let me see which one is coming up next, will be the assembler. All right. This is, as you know, factory IO goes from simple to more complicated uh, scenes, factory condition, factory scenes. So we're gonna do all of them, but we have already done this one, this one, this one, this one, and then we're gonna move on to this one. So this is two parts. Is the digital and the analog signals. So we're gonna do that first, and then I'm gonna upload the video as soon as it's ready. Thank you guys. See you next. Ciao, ciao.